Java. What is Java? Java is a programming language and a platform. Java is a programming language. Java is a high-level, robotics, object-oriented, and secure programming language. Basically, Java is used to perform programming. It is a high-level language. Maybe you know about high level language and low level language. Low level language is a machine language that is in the form of 0 and 1. But high level language is a combination of English and syntax of programming language. It is difficult for a human being to use low level language because human being can't remember 0 and 1 format. So Java is a high level language. Robotics means error free. Object oriented means Java using the concept of object oriented programming as we discussed in our theory lecture, inheritance, classes and objects. Java is also a secure programming. Why Java is secure? We will discuss about it in next slides. Java was developed by Sun Microsystems, which is now the subsidiary of Oracle. In the year 1995, Java basically developed by Sun Microsystems in 1995. The father of Java is James Gosling, who developed the Java. James Gosling. Before Java, its name was Awk. Since Awk was already a registered company, so James Gosling and his team changed the name from Awk to Java. Hello students, now it's clear. Message me in the chat box. I repeat it in a short. Java is a programming language. It is a high level language, robotics, object oriented and secure programming. Java was developed by Sun Microsystems in 1995 and Java is developed by James Gosling. The old name of Java was, or you can say original name. Then it is changed from Awk to Java. Java is platform independent because it is different from other languages like C, C++, etc., which are compiled into platform specific machines, while Java is once write and run anywhere language. A platform is the hardware or software environment in which a program runs. Basically, Java is a platform independent because when we compile our code, it will be converted into bytecode, and that bytecode will be executed by Java runtime interpreter to generate outputs. That's why Java is platform independent. About this, Why Java is platform independent, it dependent. This is discussed in next slides in detail. So basically, when we compile or run our program in C, C++, it directly converted into machine level language. So that's why C, C++ are platform dependent and Java is platform independent. So what is a platform? Platform is a hardware or software environment in which program runs. For example, your computer system, it's software environment means your computer window, Windows 7, Linux operating system, etc. And hardware environment means your motherboard, your architecture requirements. So platform is a combination of hardware and software environment. We will discuss about it in detail in the coming slides. When we working in Java, uh, there will be Java environment in which you write your program and execute. Firstly, Java is can be classified as two categories: JDK and JSL. JDK is Java Development Kit. Development tools enclosed in this. Basically, JDK is a package which contains development tools. JSL, Java Standard Library, also known as Application Programming Interface. It contains classes and methods that we will use in our programming. Firstly, JDK, Java Development Kit. From name, it's clear. Java Development Kit means tools used in development of Java programs. JDK is a collection of tools used for developing and running Java programs. They include, firstly, applet viewer for viewing Java applets. When we study about applets and implement program of applets, then we use it Java applet viewer. Java C, Java compiler. C for compiler, Java C means Java compiler. Java compiler which translates Java code to bytecode files that interpreter can understand. Basically, Java compiler used to compile our code. As we know in Java, so our program will be converted into bytecode and then bytecode will be interpreted into machine code. So Java compiler will be translate our source code into bytecode. Next is Java. It is also known as Java interpreter. Java interpreter which runs applets and applications by interpreting bytecode. Basically, Java compiler convert our source code into bytecode and that bytecode will be run by Java interpreter. Java doc, create HTML format documentation from Java source code. It will take our source code and convert into HTML format. Java H, produce header files for use with methods. The last one is JDB, Java debugger, which helps to find errors in program. Basically, debugger is used to find errors in our program. So in Java, Java debugger helps to find error in Java program. These tools are used to build and run application programs. Now our topic is Java compiler. Java compiler reads Java source code files and compiling them into executable code. That is also known as bytecode and intermediate code. The syntax for Java compiler is Java C, Java, and then file name. Let us understand with the example. Java C test.java. Java-C is used for Java compiler and test.java is our file name. So Java compiler is used to convert source code into intermediate code. Bytecode. Bytecode is also known as intermediate code. Our next topic is Java interpreter. Java programs are not compiled into native machine language, so they cannot be executed directly by the system. As we discussed in previous slides, that Java program is firstly converted into bytecode, and then that bytecode will be converted into machine language. Native machine language means on which it is run or executed. So Java program cannot be compiled into machine language. Means Java interpreter used to convert bytecode into machine code, because Java programs are not directly converted into machine language code. Bytecode run by Java interpreter. Then syntax for Java runtime interpreter. Java file name. For Java compiler, we use Java C, and for interpretation, we will use Java and then file name. Example, Java tester. Java is used for Java interpreter and test is our file name. One thing you should note here, that when we compile our program, we use .java extension, and when we interpret our program, we don't use .java extension. Firstly, we will compile our program by using Java C test.java, and then we interpret that bytecode by using Java test. Test is the name of our program. Now we will discuss some points that you should keep in mind while programming, implementing practical programs. Firstly, save your program with extension .java. For example, test.java. If you create any document in Word, you save your file with .doc, and similarly in Java program will be saved with .java. Firstly your program name and then .java. File name must be saved same as class name. In Java program, we will create a class, and in class we will implement our requirements, our program code to implement to gain a required output. So program will be saved as class name. For example, we take public class test, so that's why we are saving our program as test.java. If you use any other name of class, then you will save as that name. For example, if we create a class, public class ABC, then we will save it as abc.java. Next point is file name is case sensitive. If class name is test, note that here is a T is capital, but if you save your program test.java, all characters in lowercase, then it will not run. If you take T as a capital, then you have to save as T capital and remaining letters as small. In short, your class name and your file name should be same. We can say carbon copy. Otherwise, your program will not run. If I want to save this program, public class hello world, then we save as hello world.java. Here H will be capital, W will be capital. Our next topic is JVM. Full form of JVM is Java Virtual Machine. It is an abstract machine. It is a specification that provides runtime environment in which Java bytecode can be executed. Abstract machine means it is virtual, not in real. It provides runtime environment to Java interpreter to execute Java bytecode. Basically, we write our program and Java compiler converts source code into bytecode. Bytecode will be converted or executed by Java interpreter into machine code. And JVM provide an environment. Basically, Java interpreter run bytecode with help of JVM. JVM are available for many hardware and software platforms. So now note here one important point that JVM is platform independent. JVM is platform dependent, which makes Java program platform independent. If you are using Windows operating system, then there will be a JVM for Windows, and if you are using Linux operating system, then there will be Linux JVM. So with the help of JVM, our Java is platform independent. Firstly, JVM is platform dependence. Java bytecode can be written once and then run on multiple platforms. Java bytecode doesn't need to be ported to a specific hardware environment because it runs in Java virtual machine. Any application compiled into Java bytecode can be run on any computing platform that has a Java virtual machine. Basically, bytecode can be written once, means when we compile our program, the bytecode can be run on any platform. Means bytecode can be run on Linux, Windows, any other operating system. Java bytecode can be run independently due to JVM. Then security. JVM provide us security. Last topic was platform independence. Due to JVM, Java is platform independence, and due to JVM, Java is secure. Java was written with security in mind. The Java virtual machine has built-in security features that allow programmers to write highly secure Java programs. It also prevents malicious software from compromising the operating system because it keeps Java application from interacting with the operating system resources. Basically, there is some built-in classes and methods to provide the security in Java program. And secondly, this is described in diagram that JVM, Java virtual machine, is interacting with the operating system. Firstly, Java source converted by Java compiler into bytecode, and bytecode will be converted by Java virtual machine on operating system. So if someone modify our bytecode, then JVM will execute according to that. So security will be maintained because our bytecode will be executed in JVM, because Java virtual machine provide us environment for running our Java programs, because program will be run on JVM, not operating system. JVM will be interact with the operating system for executing the program. Due to JVM, Java program that run on Java virtual machine tend to perform slower than equivalent programs written in C++. The system neutrality of bytecode acts as an disadvantage where performance is concerned. This is because code optimization relies heavily on system-specific features. Since Java bytecode is system neutral, it cannot be optimized for specific hardware set. Due to JVM, our program will be executed slower as compared to C++ because bytecode is system neutral, means platform independent, system independent, architecture independent. To be a code optimization, it must be system specified, and due to JVM, it is a system neutral. So that's why the performance will be degraded due to the JVM. Correctness. A program that performs as expected is said to be correct. Since a Java program relies on the Java virtual machine to execute it, JVM must be free of errors for the program to operate correctly. This relies on Java virtual machine introduces as possible point of failure for the program. Luckily, Java virtual machine software is produced with a high standard and therefore it is not likely to ship with any errors. Regardless of failure in Java virtual machine is possibly that should be considered. JVM provides correctness in the program because JVM must be free of errors for the program to operate correctly. Java virtual machine software is produced with high standards, means if there can be some errors and there are some solutions in JVM. So JVM provide correctness. If JVM is fail, then there is a possibility, otherwise JVM provide us correctness. This is all about JVM. JVM provide us platform independence. JVM provide us security. JVM provide us correctness. But there is only one disadvantage, that JVM lower the performance of our program. Next, there is a simple program with Java and C language. C++ language. In C++, we write a hash include iostream.h. The header file used for input output streams. Hash include connew.h for displaying our information. Void main. Our main function void means not returning anything. And here we print hello C++ programming using function cout. As you know, because you had done C++ in last semesters, so cout is used to display any information. If you want to display your name, then you can type here instead of hello C++ programming. Similarly, in Java programming, our structure will be like this, displayed in Java. In Java, public class hello world. Firstly, we will create a class which access specifier should be public, and this is our class name hello world. And we will also save our program as hello world.java because our class name and program name must be same, otherwise it will not be run. Then there will be a main class, public static void main. Public is access specifier that it can be accessed publicly. Static means it will take only one copy in the storage, and all other classes will use that copy. Void means it will not return any data. Main, its main function, and string args, that is a parameter passed to our main class. Then start the body of this class, system dot out dot println. This is used to display any message into a Java program. S must be capital and the rest of alphabets should be in lowercase. Then hello world will be displayed here. If you want to display your name and anything else, then you can write instead of hello world. This is a simple program to display a message. Keep in mind that if you start a class, then close the parentheses body of that class.